In Chapter 7, we will have a brief introduction of Hidden Markov Model (HMM) technique. As a statistical analysis model, it was founded in the 1960s. In the year 1980s, it has been spread and developed and become an important direction of signal processing. It has been successfully used in speech recognition, speech synthesis, behavior recognition, text recognition, and fault diagnosis. Before the study of HMM technique, we had better to know some prerequisite knowledge, including Bayesian theory and the Markov process. Bayesian theory, also called Bayes' rules, is a basic tool in statistics. When the outcome of nature of an event cannot be accurately known, such as classification, prediction problems, the specific nature related to the event can be observed, and the probability of its essential attributes can be judged based on the occurrence of the event. Bayes' rule can be expressed in a mathematical expression as the posterior probability because the similarity or likelihood multiplied by the prior probability and then divided by standard constant. That is, the posterior probability is proportional to the product of the prior probability and the likelihood. For example, in the classification problem, the posterior probability is the probability of ith class under the observation O. Before the use of Bayesian rule, the prior probability of ith class should be given firstly. The likelihood is the conditional probability of the observation when knowing the classification. If the probability of an observer is larger than the threshold, the observer is classified into the class Ci. In mathematics and physics, a deterministic system is a system in which no randomness is involved in the development of future states of the system. A deterministic model will thus always produce the same output from a given starting condition or initial state. A system that cannot be described by a certain amount among the various factors of the system or system that presents uncertain information is called non-deterministic system or uncertain system. In deterministic system, here is an example of traffic lights. A sequence may be red to red amber to green to amber to red. This sequence can be drawn as a state machine. Different states alternate with each other according to this state machine. Each state only depends on the previous state. If the current one is green, then the next one is amber. This is a deterministic system, so it is easier to understand and analyze as long as the state transitions are known. There are many uncertain systems in practice. Here is an example of weather forecasting. We hope to predict future weather conditions based on current weather conditions. Unlike the traffic light example above, we cannot rely on existing knowledge to determine the shift of weather conditions. We will use weather model hypothesis. Each state of this model only depends on previous state. This hypothesis is called Markov hypothesis. This simplified system allows us to obtain some useful information, although not very accurate. All systems that can be described in this way are a Markov process. Markov is a mathematician of the former Soviet Union. He is a Chebyshev student and obtained achievements in probability theory, number theory, function approximation theory, and differential equations. The most important work of Markov was between the year 1906 and 1912, when he proposed and studied a general scheme that can be used to study natural process by mathematical analysis methods, that is Markov chains. Markov process is a discrete random process with Markov properties in mathematics. That it is a modeled random process. If the future of a process only depends on the present and not the past, then the process has Markov properties, or the process is called a Markov process, a modeled random process. After conducting in-depth research, Markov pointed out, for a system, in the transition process from one state to another, there is a transition probability, which can be calculated based on the immediately preceding state. The transition probability has nothing to do with the original state of the system and the Markov process before this transfer. A Markov process with discrete time and state is called a Markov chain. Markov chain can be represented with a series of discrete states Xn, which are the results of observing the discrete states in the discrete time set. The state space of the Markov chain is written as I. The conditional probability Pij is the transition probability of the state Ag at the time m plus n when the Markov chain is in the state Ai at time m. In Markov model, that is a k-information transition probability matrix. Considering the first-order Markov process, in which the transition of each state only depends on the previous one state. For example, weather forecasting problem contains 3 states: sunny, cloudy, and rainy. The initial vector defines the probability of the system state at time 0. Transition probability matrix show the probabilities of weather states transition. As is shown in the table, each value in the matrix is the probability of one weather state to another. In other words, if it was sunny yesterday, the probability of being sunny today is 0.5, and the probability of being cloudy is 0.375. Note that the sum of the probabilities of each rule is 1. To initialize such a system, we need to determine the possible conditions of the weather on the starting day and define it as an initial probability vector, also called the initial vector. Markov model represents the joint probability distribution of the observation sequence. If the conditional probability of xn is only related to the previous day's xn-1, we could use first-order Markov chain to define the joint probability of n-order observation sequence. If the conditional probability is related to the previous 2 days, there will be the second-order Markov chain. That's all for this session. See you next session.